Question 6 then is our standard binomial distribution question. We've got, how many have we got here? We've got 10. It's telling us there's 10 things. So x equals the number of balls that fail the test. And x is a binomial, 10 of them, and the chance of failing is 0.15. Question 1 says at most 2, so that's less than or equal to 2. We can just look that up straight away on our table. Here's my normal table, my binomial table. N is 10. I want 2 on the 0.151 there. I'm looking at that value there. 0.8202. 0.8202. Then the probability of being at least 2. So I want to be 2 or 3 or 4 or so on. That's 1 minus the probability that x is less than or equal to 1. Go back to those tables and look up 1. It gives us 544. So the answer 0.4557. Now this one here takes me, just got to do a little diagram, takes me a while just to check I'm getting the right things. I always write this little thing out and think what I want. I want more than 1, so I don't want 1. I want 2 or 3 or 4. I want fewer than 5, so I don't want 5. So what do I want? These are the ones I'm looking for. I'm going to look up less than or equal to 4 and work out that out. And then I don't want these ones down here, so I'm going to take away the less than or equal to 1s. So looking up 4 is 0.9901. Looking up 1, well I did that earlier, 0.5443. And so one take away the other is 0.458. Just doing one take away the other. The second part of this question is actually really not much more than that. It's a bit dull really. You just increase it to 5 boxes now, and so now we're just looking at a new table. The new table, because there's 50, 5 tens 50, and still the chance of them failing is 0.15, and we want the probability that x is more than 5. Again, think about what does more than 5 mean. It means 6 or 7 or 8. So that means we don't want less than or equal to 5. So now looking up less than or equal to 5, now not on the 10 table, but scrolling down till we get to the 50 table, and the 0.15 and 5 value there is the 0.2194 value there. So just sticking that in there. 1 take away the 0.2194, that probability is 0.7806. And again, at least 5, but at most 10. They're just trying to confuse us, aren't they? So what do we got? At least 5, happy with 5 and 6 and 7 and 8 and 9, at most 10, happy with 10, not happy with 11. So we're looking at the probability that x is less than or equal to 10, and we're taking off the probability that x is less than or equal to 4, and tapping those in there. So that one there, the 10 value, 8801, the 4 value is 1121, and I'm getting 0.768 to finish that off at.